Hi all, welcome to Dr. Whiteboard Talks again. Today our topic is CSF circulation. So how the CSF is formed, from where, and how it is transported, or like it is circulated inside, from inside of the brain to the outside of the brain. That means, as we know, that brain is immersed in the CSF fluid. That means we have to say inside and outside of the brain is fulfilled with the CSF fluid. So this is the reason why 1.5 to 2 kg of brain is there in our head inside, but we don't feel that much head weight. So this is the reason why we say, as the fluid is covering the brain from inside and outside, it feels like it is immersed underwater. The same effect is there. That is the reason we don't feel our head is too heavy and to walk and all, but still it is heavy. So today we are talking about CSF circulation. So how it is formed, from where, and how it is being transported. So in this case, the diagram. We'll come to this diagram again, but we'll describe this diagram again. But today, right now, we'll go with how the CSF is produced. Actually, CSF is produced by the choroid plexus in the lateral third and fourth ventricles. So it is actually choroid plexuses that are making the CSF. So CSF is produced by the choroid plexus. Okay, so the choroid plexus is the one which forms the CSF, and then later this is circulated through the subarachnoid space between the arachnoid and pyometer. So through the subarachnoid space between arachnoid and the pyometer of brain, the covering of the brain and spinal cord are the meninges. So this meninges, we have two differences in meninges. Actually, we have like the meninges covering the brain and the spinal cord has some differences, but we'll come to that later. Right now I'll tell through the subarachnoid space between the arachnoid matter and the pyometer. Okay, now when the difference between the brain and the spinal cord meninges is that the spinal cord dura mater, is like, it does not, the spinal cord dura mater does not form any dural fold, but the brain dura makes a fold. So there are foldings in the brain dura. I'll tell this like this. If you observe, here we have the dura mater, arachnoid matter, and the pyometer. So I'll write here as that is the dura mater, we have the arachnoid matter, and we have the pyometer. If you observe this, this is the dura mater. So this dura mater actually fold inside like this way. It is folding inside of the fissures of brain, and then inside that the dura is folding the same way arachnoid matter is also folding. And we have the pyometer, which is the intimate layer of the meninges which is covering the brain. So we have the difference, as it is like, if you come to see, the spinal cord dura mater does not form any dural folds. That means there is no folding of the dura, but the brain dura makes the fold. Also, there is a space known as epidural space. So if you note it, we have a space called epidural space. Epidural space is a space between the dura mater and the spinal cord, unlike in brain. So brain does not have this epidural space. So here we have dura mater and spinal cord. In between that we have this dural space. So dural space is there, but that is not in the brain. And unlike in brain, where there is no space separating the two, which means there is no space between dura and the brain. That means there is like, we have no epidural space like that. So it is like it is almost fulfilled with that, but the spinal cord has a epidural space. I will come to the diagram once. thus we know that what is the practical implication of that. The epidural space, if you see here, this is the brain. If you see here, we have uh, we have here the subdural cavity, but we don't have an epidural cavity. Epidural cavity is absent. So epidural cavity is absent in the brain, but when we come to the uh, in the spinal cord, we have epidural space, and this is the space where we give epidural anesthesia in certain operations. So this is the case I have to discuss about epidural space. Okay, now I'm coming to the topic. Once again, we have to see this space creates an area devoid of the spinal cord. So epidural space is the space where there is area devoid of the spinal cord. So it contains only CSF. So spinal cord is not there, but CSF is there. So it is a good site to extract CSF. To extract CSF, even to extract CSF, we have this space, that is epidural space. So coming to this, first, once again I will just sum up this. There is a difference between brain and the spinal cord meninges. In the spinal cord, dura mater does not form the dural fold, but brain dura makes a fold. That's a big point that you have to keep in your mind. Okay, now there is a space known as epidural space in the spinal cord, which means between the dura and the spinal cord we have an epidural space, unlike in brain where there is no space separating these two. And this space creates an area of no spinal cord, and there is only CSF, and this is the reason we can extract CSF. So when we come to this, here you see this is the cross section of a diagram showing the cross section of spinal cord. In that you can see this is the dura mater, and if you come to this, we have subdural cavity, that is just below the dura. Okay, so dura mater, subdural cavity, and just behind that we have arachnoid matter, and above, under that we have subarachnoid cavity. Okay, and under that intimate layer called pia mater is also there. So intimate layer pia mater is also there. So what we have to observe in this condition is like we have a space in between this, which means we have a space like epidural space which is filled with fluid. So suppose if you write or if you draw the vertebral column like this, if the vertebral column is there, like this is the vertebral column. Suppose I'm just schematic diagram shows, suppose this is the vertebral column, and what we have to observe here is we don't have a nerve or spinal cord here, but we have CSF here. So this space where the CSF is there, but there is no spinal cord, and this is the area where you extract CSF, plus you can give epidural anesthesia. Okay, so this is what about the difference between the meninges of brain and spinal cord. So coming to the brain, there we know the skull is there. Once after the skull we have again the dura is there. Later under dura we have arachnoid matter, which we have discussed earlier, and below that we have pia mater. So the green thing what we have here is the arachnoid, the red lining is this is the pia mater, and above that this is the one which we have the dura. The yellow is the dura, and this space is the one which is called subdural space. So this is the space. We have subarachnoid space even. So this is the subarachnoid cavity and subdural. The green colored is the subarachnoid, and the light green or blue we say this is the subdural cavity. But if you observe this, above that we have just intimate layers. We don't have a epidural space here. But if you observe, we have emissary veins. These are the emissary veins which is communicating diploic veins and the other vein, cerebral vein. So the emissary veins are those veins which are penetrating veins which communicate between the diploic veins of the skull, plates of the skull, or bone plates of the skull to be specific, and the cerebral brain under, or means like in the brain meninges. So these are the emissary veins. If you observe other, we have like suprasagittal sinuses is there, and arachnoid granulations are there, which are the neuroanatomic details which functionally most probably we don't want to come into this. And if this is a coronal section, we'll see this is the falx cerebri. So to sum up, there are differences between the layers of brain, of meninges in brain as well as the spinal cord. So now if we come to this diagram, again I'm just coming with this diagram as if like you observe, we have the brain in its sagittal section. Inside that we can see the lateral ventricle, the third ventricles, as well as the fourth ventricle, plus we have the apertures, plus we have aqueducts and all. That is how, where the CSF is produced. The CSF is produced in the choroid plexuses. Later it is choroid plexuses of all the all the ventricles, like fourth ventricle, like third ventricle, and we have also the lateral ventricle. So in all those cases, once after the CSF is formed, the CSF then circulates in a fashion that inside the brain it is formed, and it is reaching, washing out or bathing the complete brain outside uh, under the layers of meninges, and also it communicates throughout the spinal cord. So this is the spinal cord area. We have subarachnoid space of the spinal cord which is washed with cerebral spinal fluid. Once after that, this is observed, or this is like taken, absorbed by the emissary veins as well as through the sinuses. This is joining into the sinuses, like superior sagittal sinuses, as well as also from the veins surrounding the spinal cord. So we'll come to the details of it. Okay, so we'll be coming to the discussion of this diagram once again in a detail. Now let me come to this as if like what I have told right now. CSF is produced and flows from the choroid plexuses. So choroid plexuses are the areas where it is formed, and mainly in the lateral ventricles. Okay, from the lateral ventricles, what happens is, this lateral ventricles, later the CSF is transported, or even it is circulated into the third ventricle. Okay, and once which is formed in the fourth ventricle, that is like if it is like formed in the fourth ventricle, this is being trans or circulated via foramen of Monroe and cerebral aqueduct respectively, which means the lateral ventricles from there into the third ventricle, and then from lateral ventricles to the fourth ventricle, it is transformed, or it is like circulated with the foramen of Monroe and cerebral aqueduct respectively. So from lateral ventricle to third ventricle, it is through foramen of Monroe, and from lateral ventricle to cerebral aqueduct, it is through, sorry, fourth ventricle, it is through cerebral aqueduct. Okay, so we'll come to the diagram once again. So suppose this is the lateral ventricle, and we have the choroid plexus here, and we have the third ventricle here. So this is transported or is circulated through the aperture like this. So this is the area where we call foramen of Monroe, where it is transported or is circulated to the third ventricle. So from the lateral ventricle to the third ventricle through foramen of Monroe, and then to the fourth ventricle. Here we have again the fourth ventricle. If you see this, you have cerebral aqueduct. This is the area from third to fourth ventricle. So from third to fourth ventricle, it is transported or is circulated through cerebral aqueduct. So these are the two areas where it is formed inside, and it is now reaching fourth ventricle and third ventricle. From there, what happens is, from the fourth ventricle, the CSF empties into the cisterns of the skull through foramen of Magendai and foramen of Lishka. So these are the two foramens. These empties into the cisterns of the skulls, and from there it goes into the lumbar CSF space. So lumbar CSF space and the subarachnoid space at the sagittal sinus. So this through the foramen of Magendai and foramen of Lishka coming to the lumbar CSF space, that is in the spinal cord, plus it is in the sagittal sinus. So from inside it is coming outside through the main areas of foramen of Monro and cerebral aqueduct, later through foramen of Magendai and foramen of Lushka to subarachnoid space and lumbar CSF space. Okay, so this is the flow of cerebrospinal fluid. Now the cardiac contraction includes a arterial distension. As we know that cardiac contractions can cause arterial distension during the systole and subsequently recoiling during diastole. There is a recoiling. Once during diastole, there is a recoiling, and there is an arterial distension during contraction. As a part of this, there is some energy which is formed. Some energy is transferred to the brain in the form of brain pulsations. So this is called as brain pulsations. Once the brain pulsations, this is transferred as a brain pulsations, will affect CSF in the form of CSF pulsations, and this dissipation of arterial blood flow energy by CSF pulsation energy provides the maintenance of low intracranial pressure, and this effect is called as, we have Wind-Kessel effect on CSF flow. So this is called as Wind-Kessel effect on CSF flow. So this is a simple topic which we have discussed, how the CSF is formed and it is transported outside the brain. So this is just for a basic understanding of how the CSF is formed. Maybe many of you know it, but still I have to just for the purpose of completion of this topic, I just mentioned about the main important areas where the spinal cord is where the CSF is formed and how it is transported. Now, this is a flow chart where the lateral ventricles, through that to the third ventricle, to the cerebral aqueduct, then into the fourth ventricle. So here we have foramen of Monro. We have the foramen of Monro, and from there to the cerebral aqueduct it reaches the fourth ventricle, and from the cisterna magna, which means that they are coming to the cisterns. From cisterns, it is reaching to the lumbar CSF space as well as subarachnoid space, and then from there it is reaching the sagittal sinus. So these are the cisterna magna, which means that what are the cisterns? This foramen of Lushka and foramen of Magendai, which are the two areas where they transport later. So this is a small diagram which shows the circulation. Once again, it is formed inside the brain. Inside the brain, it is formed like here. Then it is transferred like this from here to the third ventricle, from lateral to third to the fourth ventricle, and from there it is through the foramens respectively, it is going up to the sinuses, plus it is going down to the lumbar cisterns. So this is a way how CSF is formed, and it is birthing the brain and the spinal cord. And we have told about what are the differences between the three layers of the meninges, and what are the difference between the meninges of brain and meninges of the spinal cord. So sum up the topic, we have CSF circulation, how it is like formed, and where it is formed and how it is transported, the main difference between the epidural space, plus the main difference between the meninges of brain and the spinal cord. Then we have the diagram of how the meninges of spinal cord and the brain is organized, and from there what is the difference between and what is the advantage of epidural space I have mentioned, and what is the function, what is the way you get the transportation, or what we call it as circulation of CSF inside the brain, and the effect how the arterial distension and the diastolic recoiling affects the CSF pulsation as the energy transferred, brain pulsations plus the maintenance of low intracranial pressure causing in the brain as this is called as Wien Kessel effect on brain CSF flow. Okay, so now we'll come with another topic in the neurology. Hopefully, I hope this topic was useful. Just for an introduction purpose, CSF plus how it is formed and circulated. So formation and circulation. These were the topic which we discussed right now. So thank you for watching. Shall see in another video.